Hey, today I would like to show you how I simulate Monty whole problem using TypeScript. So basically the problem is, imagine that you are on the game show with three doors. One hides a car and others hide goats. You picked one door, say for example door 1. The host, who knows what behind the doors, opened another door, which is door 3, revealing a goat, and asking if you want to switch to the door that you didn't pick, which is door 2. Should you switch in this case? The answer is yes. You have 2/3 probability to win the car if you switch, while you only have 1/3 probability to win the car if you stay with initial choice. Feels very counterintuitive, right? Let's forget about all the mathematics, just write some code to see it in practice. So here is a code. First, let's define the type content, which represents the thing can be behind the door, which is either car or goat A or goat B. And then define the situation, which represents the possible combinations of contents behind all doors in one trial. And then define valid door contents and valid doors for future usage. And then let's find out all possible situations by enumerate them. So after excluding those door content, those situations that have duplicated content, which is impossible, then we could print out and see what are the possible situations in total. So there are 6 of them. And here is a table shows what are the possible combinations in each round for the contents behind the door. And then let's brute force the gaming mechanisms by 1,000 times and track the number of wins by keep the initial choice and the number of wins by switch to the new choice, new door. And then the simulation data is an array to track the a structured data consisting of trial number, situation, the pick door, and could you win by keep, and could you win by switch. So for each round, let's pick a situation randomly from all possible situations. Remember, it's 1 out of 6. And then let's pick a door, which is 1 out of 3. And then for the host, we know that what are the remaining doors and where is the door that with a goat from the remaining doors. And we need to, the host need to open that to show us. And then we could find the door to switch, which means from the remaining doors other than the ones that the host already opened, that close the door is the one that we can switch. Then from here we could detect if our picked door has car behind it, then we will say this we could win by keep, and then add +1 to the number of wins by keep. And if the door that we can switch has a car behind it, then we say we could win by switch, and then +1 to the number of wins by switch. This loop will be executed 1,000 times, and we use console table to print out it. And then let's have some statistics, which will show us the total number of trials, the number of wins by keep and its ratio, the number of wins by switch, and the ratio. So let's run it again and see what happens. So it will give us a giant table, tracks like what are the situation, what is the trial number, and what are the our initial picks, and could we win by keep or could we win by switch. There are thousands of them, and then the statistic will show like how many times that we could win by keep and how many times we could win by switch. The numbers shows that there are around just 300 times that we could win by keep our initial choice, and there are about 600 to 700 of times that we could win by switch our choice. We could even run it multiple times and see how the numbers change, but it's roughly close to the 2/3 and 1/3 of the probabilities from the mathematical answer. So yeah, we do see it in practice with the TypeScript code. So I have uploaded the script to GitHub. Feel free to have a try by yourself. And if you want more explanation, I would recommend this video on YouTube. Thanks for watching.